Okay, we're going to work on collecting like terms, but this time we're going to work on them with algebra tiles, and then we'll do them with just straight algebra, so no manipulatives, which are these pictures here. So the very first thing we have to do, and we've kind of talked about it before, is we have to represent each of these terms, right? And there are 1, 2, 3, 4, 5 separate terms in here. Every term is separated by either an addition or a subtraction sign. Okay. Now this says 3 times c squared, but that is all considered one term. Okay, so when something's multiplied or divided by each other, that's just one term. Only the addition and subtraction signs separate. We're going to represent these. Now, c squared, in this case, they've written as c, but it's our variable, right? So it's also known as our x. So these blocks here represent our c squareds. Now, how many c squareds do we have there?
We have 3.
3. So I'm going to represent this with 3 of them. We have 1, 2, and 3. Doesn't quite fit on the page, but there we go. Okay, so we have, oopsie, jump up. So we have 3 of them. And then our next one, zoom out just a little. Okay, and our next one, we're looking at just this term c. Well, the term c is
X.
our x term. Excellent. So how many c's are there?
There are just 1 c.
That's 1. So we represented it with just 1. Okay, I'm just going to turn them sideways so we have some room. Up and down to start. The next term is what?
-2.
-2. What numbers or which of these shapes represent the negatives?
The white.
The white one.
Little tile.
That's right. That white tile is going to represent. And how many of them are there?
There are 2.
2. So we have 1, 2 of them. What is our next term?
5c.
Yep.
So 5x.
So 5. So do we take the green ones in this case?
Yep.
What is that sign in front of it?
That's the negative sign.
That's a negative sign.
So negative.
This here we represented it with a positive x. But this one is a negative. Which of these tiles represent negative x's?
The white.
The white. And how many of those do we need?
5.
That's right. So we're going to take 5 of these guys. Let's put them a little lower so they'll fit, okay? And we need 5 negative of these tiles. 4 and 5. And then finally, I guess we're going to have to move them over a bit. What's that last term over there?
4c to the squared.
4c squared. And is it positive or negative?
It's positive.
So what shape and color represents that for us?
That would be the x. Oh, sorry. That would be the green x squared tile. You need 4 of those.
Well, the green one represents...
Oh, sorry. That's positive. So negative.
The negative, we need the white one. So you're right. We're going to need 4 of these, right? So we have 1, 2, 3. Let's split this little 4. Okay? Now, what I want us to realize here is we can do something it's called creating zeros. Helps us eliminate terms, okay? Now, this is a 1 positive x squared, and this would be considered 1 negative x squared. Well, a positive 1 and a negative 1 put together create a 0. So in other words, when I combine these two tiles, they create 0, or a lot of times they know it as canceling something out, okay? So what we're going to do is we're going to match up tiles. So I have this one here. Can I cancel out a white one with it?
Yeah.
Yeah. Can I do it again?
Yep.
Okay. Can I do it again?
Yep.
Can I do it again?
No.
No. Do I have any positive x squared tiles left?
No.
No. Do I have any negative ones?
Yep.
How many?
1x squared.
All right. So we have
negative.
So negative 1 x
1x
squared is left there. Those only like terms, and the like terms have to be. Do you see how they're squares? Only the squares are the like terms, or in this case, are squared values. Our like terms in this one are our variables. Okay? Yeah, there's our variables. So I'm going to do that again with our variables. A green and a white one will cancel each other out. Can I cancel out the green one with a white one?
Yep.
Can I do it again?
No.
No. How many am I left with?
Negative 4x.
That's right. There's 1, 2, 3, 4. So we have negative 4x. And finally, my constant terms. So I'm just going to highlight what we did collect as like terms. These guys and these guys, these were all the squares. The blocks were our C's, and I only have one constant term. Is there anything to combine it with?
No.
No. So I'm just left with what I got. I can't cancel anything. I have -2. Now here's the original question. What were the variables though? Were they X's?
No, they were C's.
They were C's. So let's jump down and turn this into C's. So what would be my collected like term? It would be -1.
C squared. Negative. Oh, minus.
Yep.
4x.
Not X. We have to change
4C.
it. Good.
-2.
Excellent. So that's doing it with algebra tiles. We got a little time. So I'm going to jump ahead here. In this version, I have no algebra tiles. I just have to recognize my like terms. Now, we talked about it before. Anytime we have a variable, like terms are terms that have variables to the same exponents. Well, in this one, these are the only two to the exponent 2, which means they have to be the like terms. Okay? So I highlight 3c squared, and it doesn't matter the coefficient, which is the number in front, as long as the variables are to the same number. Which means these guys here, what are their variables to?
To the power of 1.
That's right. And both of them to the power of 1. So are they like terms?
Yep.
That's right. Just like we had in our other question. And finally, I'm going to add a little something to this, okay? I'm going to say m plus 8. My like terms here, notice they don't have any variables. They're just constant terms.
Yep.
Okay. Now it could be said, if you remember your variable rules, what if I said this was c to the power of 0? What is something to the power of 0? Do you remember? 1. So that would be 8 times 1. What's 8 times 1?
8.
Exactly. So I didn't even need to write it in. And they look like they're two variables with the same exponent in that case. But we don't really think of it like that. Let's just think of it as constant terms. So those are our like terms here. Okay? So with these all being our like terms, now we just got to do adding and subtracting of integers. So I focus on the coefficients in front of all of them. So the coefficients in front of my first terms, I take the terms with the highest variables first. Combine those. That is +3 and -4. What do they become?
-7.
Not quite. Think of adding them together. So this is +3 plus -4, which is the same as writing 3 minus 4. To make
Which
that equal.
is -1.
That's right. So that becomes -1c squared. Now, what coefficient is in front of that?
That's 1.
1. This is 1 minus 5. What is 1 minus 5? 1 minus 5 is equal to
That is equal to -4.
-4. So we have -4c. And finally, I have -2 and 8. When I combine those, what do I get?
6.
Positive or
Positive
negative?
6.
Positive 6. Okay. Now, if you notice, if I hadn't added the 8, it would have just been -2, right?
Yeah.
And then in that case, let's go to a page. You would have noticed that our answers for these two questions were the same. See how there was a -2 and then this one was -2? The only reason they changed a little is because I added an 8 to that question because I wanted us to do some combined. So once we understand the concept of what our like terms are, we don't have to put all of these tiles in. We can just look for our like terms and collect them ourselves.